Let's start with a simple question. Why is the sky blue? We're lifting off from a desert on Earth, punching up through the troposphere. This first layer is only about 4 to 12 miles high, but it holds 80% of our atmosphere's mass. The sky is blue because air molecules scatter blue sunlight more than other colors. But as we climb higher and the air thins out, what happens to that color? We're officially crossing the border into space. At an altitude of 62 miles, we've passed the Kármán line. The sky goes black up here because there are hardly any air particles left to scatter the sunlight. To get this high and escape Earth's gravity, you need to be traveling at a staggering 25,000 miles per hour. So, what's it like to be one of the fastest travelers in human history? Now we're pulling back for some perspective. We're in low Earth orbit where the International Space Station lives. To keep from falling back to Earth, everything here has to move at 17,500 miles per hour. That's fast enough to get from New York to LA in about 10 minutes. From here, you can see all of civilization's lights at once. Which city would you look for first? As we leave our home behind, you can see the moon. It doesn't look that far, right? But that gap is about 238,900 miles. You could fit every single other planet in our solar system into that space. Even for light, it's a 1.3-second trip. For the Apollo astronauts, it took 3 full days. Could you handle being in a tiny capsule for that long? We're turning our attention to the heart of our own galaxy, the Milky Way. Our destination, Saturn, is just a tiny point of light from this distance. We're looking at a structure that's 100,000 light years across, and at its center is a supermassive black hole 4 million times the mass of our sun. Does seeing that make you feel small or part of something enormous? Let's get closer. As we push forward, notice how the closer stars seem to shift faster than the distant ones? That's called parallax, and it's how astronomers measure distances in space. It's the same reason trees on the side of the highway fly past your window, but distant mountains barely seem to move. Our own trip to Saturn covers a minimum of 746 million miles. How long do you think that takes? It took the Cassini probe nearly 7 years to make that journey. As we get closer, we're entering Saturn's family of moons. These aren't just rocks, they're entire worlds. The largest one, Titan, is bigger than the planet Mercury. It's also the only moon in the solar system with a thick, nitrogen-rich atmosphere, a lot like Earth's. What do you think we might find under those clouds? We've arrived. Those iconic rings are one of the most beautiful and bizarre things in the solar system. They span 175,000 miles wide, almost the distance from the Earth to the moon. But in most places, they're only about 30 feet thick. They're not solid. They're a blizzard of orbiting ice chunks, from dust specks to the size of a house. What force could possibly create something so massive, yet so thin? Nature doesn't usually draw straight lines, so what in the world is this? As we get closer to Saturn's North Pole, you can see it. A perfect hexagon. This isn't a small feature. It's a storm wider than 2 Earths, with winds inside screaming at 220 miles per hour. This is a massive jet stream, a kind of stable wave in the atmosphere that's been locked into this bizarre geometric shape by the planet's rotation. How can a weather pattern be so perfect? Saturn's most famous feature is also its biggest illusion. We're diving toward the rings now, and from a distance, they look solid. But they're not. While they stretch out for 175,000 miles, in most places, they're only about 30 feet thick. That's like a single sheet of paper the size of a city. The huge gaps you see, like the famous Cassini division, are kept clean by the constant gravitational pull of Saturn's moons, which fling any stray particles out of the way. So if they're not solid, what are they really made of? Let's get even closer. See all those fine lines? They look like grooves on a cosmic vinyl record, and they're made of 99.9% pure water ice. The particles range in size from tiny dust grains to chunks as big as a house. These grooves aren't random. They're the result of density waves, which are spiral patterns formed by the gravitational tugs of nearby moons. They bunch particles together in some spots and spread them out in others, writing a story of gravity across the ice. What would it be like to actually fly through them? It looks like a gentle, silent snowstorm, but this is one of the fastest moving environments in the solar system. We're now inside the rings, and while it feels like we're just drifting, these ice chunks are moving at over 50,000 miles per hour, many times faster than a rifle bullet. Each particle is its own tiny moon, but since they're all moving together, it feels calm. It's the constant, gentle collisions between them that keep the entire system so incredibly flat. So where did all this debris come from? We're floating through what might be a cosmic crime scene. The leading theory is that these rings are the remains of an ancient moon that strayed too close to Saturn. It crossed a point called the Roche limit, where the planet's tidal forces were stronger than the moon's own gravity, and it was torn to pieces. All this material, about 33 quadrillion tons of it, is the leftover debris from that violent event. But even that's only half the mass of Saturn's tiny moon, Mimas. Are we just flying through the ghost of a shattered world? Here's the strange part. These beautiful rings won't be here forever. They look dense, but they're mostly empty space, with particles separated by anywhere from a few feet to several miles, and they're actively disappearing. A phenomenon known as ring rain is pulling these ice particles into Saturn's atmosphere. The sun's radiation charges the ice, and the planet's magnetic field just sucks them in. This whole magnificent structure is slowly being drained away. If they're disappearing, does that mean they're new? Saturn is ancient, but its rings might be younger than the dinosaurs. The biggest clue is how clean they are. Data from the Cassini mission suggests they could be just 10 to 100 million years old, a mere blink in cosmic time. If they were billions of years old, they'd be dirty and dark from collecting cosmic dust. Instead, they're made of bright, pristine water ice, which tells us they formed relatively recently. What does it mean that our solar system is still changing so dramatically? As we leave this icy wilderness, let's just appreciate the scale. The entire main ring system is over 175,000 miles wide. That's wide enough to fit almost the entire distance between the Earth and our moon within its span, and it all exists in a perfect, delicate balance. Saturn's gravity pulls every single ice chunk in, while their incredible speed tries to fling them out. It's a cosmic tug of war, held in equilibrium by the planet and its moons. What other temporary wonders are still out there, waiting to be found? How can something wider than 20 Earths be thinner than a football field? As we pull back out of this blizzard of ice, we're seeing something that shouldn't exist. The main rings stretch 175,000 miles across, but in most places, they're only about 30 feet thick. If you made a scale model of this out of paper, it would be thousands of times thinner than a single sheet. It's all because of gravity and collisions. The planet's gravity flattens everything out, while billions of years of particles bumping into each other have canceled out any up or down motion. So, what does the planet that holds this impossible structure even look like? You're looking at a planet so big you could fit 9 Earths across its face, but you couldn't stand on any of it. This is Saturn in all its glory. It's a true giant, about 72,400 miles wide, with a mass of 95 Earths. Those bands you see aren't land. They're layers of clouds made of ammonia and water ice, whipped around by powerful jet streams. There's just no solid ground to stand on here. But is it all alone out here? A planet is one thing, but what about a whole system? As we pull back, you can see Saturn isn't alone. We're seeing its moons, like Titan and Rhea, labeled on screen. And that one, Titan, is huge. At 3,200 miles across, it's actually bigger than the planet Mercury. Saturn's gravity holds on to over 146 moons, creating its own miniature solar system where each moon is a unique world. But what do those rings look like from a different angle? This view right here, it's almost impossible. We're now aligned perfectly with the ring plane, and it nearly disappears. What looks like a razor-thin line is actually that same 175,000 mile wide structure we saw before, but it's only about 30 to 300 feet thick. It's not a solid object, remember? It's trillions of individual ice particles, all in their own orbit, reflecting sunlight back at us as a single bright line. What's hiding in the darkness beyond? You think Saturn is far away? Look past the rings. See that faint, cloudy patch in the background? That's the Orion Nebula, with the stars of Orion's belt right there: Alnitak, Alnilam, and Mintaka. That nebula is about 7,900 trillion miles away. The light we're seeing from it left 1,344 years ago. It's a stellar nursery, a giant cloud of gas and dust where new hot blue stars are being born, which is why it glows. It really makes you wonder what other secrets Saturn is hiding, doesn't it? There's a storm on Saturn so big that 4 Earths could fit inside it. And it's a hexagon. As we pull back again, we can see the North Pole and that bizarre shape. Each of the hexagon's 6 sides is about 9,000 miles long. That's wider than our entire planet. It's a massive jet stream, a river of atmosphere moving at 220 miles per hour. Scientists believe the geometry is a natural result of fluid dynamics, but we're still figuring out the exact details. How does a structure like that even cast a shadow? Even in the darkness of space, shadows can tell a story. As we keep pulling away, look at how the planet casts a massive shadow across its own rings. We're about 886 million miles from the sun here, so the sunlight is 90 times dimmer than it is on Earth. That shadow isn't just cool to look at. It's a perfect visual cue that shows you the 3-dimensional nature of this system, the rings passing behind the planet, blocked from the distant sun. But what happens when we go behind the shadow? This is the final, most stunning illusion of our journey. We're now looking at the dark side of Saturn. The planet is a black silhouette. but the rings are glowing. How is that possible? It's a phenomenon called forward scattering. The sun is now behind the rings from our perspective, and the trillions of tiny ice particles are scattering the sunlight forward toward us, making them light up like a celestial halo. It's a final reminder that out here, perspective is everything. What will we discover next? As we're pulling back from Saturn, it's important to remember something wild. None of what you're seeing is happening right now. It's all an old picture. The light from Saturn takes over an hour to reach us, so we're seeing the planet as it was 60 minutes ago. And see that star labeled Alrisha in the background? Its light took 139 years to get here. Every time you look at the night sky, you're literally looking back in time. Doesn't that change how you see the stars?